Right from the outset, the scheme was the subject of much criticism. People thought it could not succeed.
The pipeline to Kalgoorlie is 566 kilometres long. It's pumping 5 million gallons a day over a lift of 400 metres.
One of the things that's amazing about the pipeline is that it is still the longest pipeline of its type in the Southern Hemisphere, and it was built over 100 years ago. That in itself is an amazing engineering feat.
In building this scheme, they had to overcome not only the critics, but also the forces of nature. They'd looked at all sorts of other designs. Cast iron pipes had been ruled out for being too heavy, so then they looked at wrought iron pipes. But eventually they decided on steel.
Bundaring Weir Dam was the highest dam in the Southern Hemisphere. The pipeline to the goldfields used the innovative locking bar principle of joining the pipes together.
The locking bar pipe was invented in the mid-1890s. Meffin Ferguson, a Victorian engineer, opened his desk drawer. He saw the dovetail joint. He thumped the desk and said, "I've got it, I've got it. I can use that joint in making a pipe."
This was the locking bar. The two halves of steel were transported from London, placed in this joint, and were joined by very high pressure mechanical press, and the horizontal joint comes into here. So you have those two parts coming together with the joint sitting in the middle here, which was then filled with lead. A bit later, the caulking machine, an Australian invention, was designed to travel along the pipeline, fit over the joint. The lead was poured through that and was mechanically clamped. And as soon as that joint had solidified, the device would move along to the next joint.
This enormous contract required 60,000 pipes for a 350-mile pipeline, and those 60,000 pipes were all tested to make sure they were watertight, and only 50 of them leaked. Those 50 were put back through the closing machine and put back into service.
O'Connor decided to lay it below ground to minimise the contraction and expansion caused by the extreme weather conditions. The hostile country that it was laid in was formidable and required dedicated staff.
This innovative design proved very successful, but there were problems with when you joined one pipe to another.
They found that the lead joints were starting to leak, and throughout the 1930s it was brought above ground and put on concrete bolsters.
In the 30s, leakage was getting to the point where 50% of the water that was pumped wasn't getting to Kalgoorlie. So they decided that we've got to take the pipe out of the ground and relay it. To do this, they had to lay diversions. The pipework was raised, cleaned by hand, and then it was cement lined. The main joint, the leaded joint, was removed, and that meant that there was a section of pipe which was missing. The wood stave pipe was approximately 30-inch diameter. Timber slats were curved. High tensile wire was then wrapped around that. So they could only be laid in low pressure areas, which is what they did.
So the pipe is buried when we replace it now.
These larger pipes nowadays have a rubber surfacing on them. It's not going to corrode.
We will keep it above ground through salt lakes or in really rocky ground. But generally we bury it now when we replace it because it helps with temperature control, and it also helps with protecting it from people hitting it or external influences.
Well, the locking bar pipe had a lifetime originally in O'Connor's period of 25 years. Well, we've just gone past 115 years. These big improvements have greatly enhanced the flow rates, and it will go on for many years to come.